Thinking Machines, the 12 billion startup from ex-OpenAI CTO Mira Moretti, just dropped its first ever model. There's 975 billion parameters, it's Apache 2.0 licensed, and the weights are all on Hugging Face for anyone to download. And although it's not competing with frontier labs like Anthropic, its actual goal is to be fine-tuned specifically with its own platform, Tinker. So if you need a model that's trained on a highly specific task, then this may be exactly what you're looking for. Today, we'll cover why you'd want to use this model specifically and all of the reasons why you'd want to fine tune. And there's a super interesting way that this model processes audio and visual, which I've never seen before. So stick around and we're going to cover that as well in this video. And we cover AI topics constantly on this channel. So if you want to stay up to date, then subscribe to Better Stack. Thinking Machines are very upfront about the fact that their new model is not as strong as basically any general model on the market, and they say this in their launch post. So they're just managing expectations, and you can see why in the benchmarks. On instruction following, it does beat GLM 5.2, 79.8 to 73.3, but on terminal bench, where agents go off and actually do work, it gets beaten badly with 63.8 to 82.7. So it's good at following orders, but much weaker at working things out on its own. However, it is a great starting point if your intention is to fine tune. Under the hood, it's a mixture of experts, so there's 975 billion parameters in total, but each layer holds 256 unique experts, and each token only gets sent to 6 of them, which means only about 41 billion parameters are doing any work at any single time. It's also multi-model, so images, text, and audio all go in, and the way it does this is much different to any model you would have seen before. Normally, when a model handles audio, for example, there's a separate speech model in front of the language model that transcribes the text and then passes that transcript to the language model. Images can work in the same way. A vision encoder looks at the picture and then creates a description for the image and then passes that to the language model. And of course, doing this means that there's going to be some form of data loss along the way. Inkling doesn't do any of that. The audio goes straight in as a spectrogram, so the raw frequency bands of the sound are chopped up into buckets. Images also go in as 40 by 40 pixel patches. Both get dropped straight into the same space where the text tokens live, and the model chews through all of them together. So nothing's getting squashed down into text, so theoretically you should get much less data loss and compression when processing things like audio and visual, specifically with the Inkling model. And in fact, compared to most generalist models which don't support raw audio at all, Inkling clearly stands out. Now, whether you should even fine-tune at all comes down to your specific goals. The rule of thumb is generally that fine-tuning teaches a model how to answer, not what to know. For example, tone of voice or rigid structured output, where thousands of examples would be needed in context to guide the model's output, because passing thousands of examples via a prompt would just be impractical. Also, cost and latency distillation, where performing a narrow task with a general model would be considerably more expensive than fine-tuning a smaller model. Basically, if there's any situation where you need thousands of examples to get decent output, then that could benefit from fine-tuning. But if you need the model to know things it doesn't know, then don't fine-tune. There's actually a well-cited paper which puts retrieval up against fine-tuning, and retrieval won consistently. And if you want better reasoning, then fine-tuning can actually make it worse because it degrades the model's chain of thought. And interestingly, smaller models suffer the most. But specifically for narrow jobs, the results from fine-tuning can be great. If we take Harvey, who build AI tools for law firms, they trained a small model to pull citations out of legal documents. They scored its F1, which is a metric used to evaluate the performance of a classification model, and fine-tuning took them from 0.56 to 0.68. And head-to-head against GPT 4.0, the smaller model won or tied 93% of the time, and it even ran faster. Thinking Machines even show a demo forcing Inkling to never use the letter E, where you can literally prompt it to fine-tune itself via Tinker. It then goes off and creates the training data set and can run the full fine-tuning process completely automatically. And the result of this is a model that has severe epsilon phobia, and somehow the responses still make sense. But you're not retraining the entire model here, you're actually using something called LoRA, which stands for low rank adaptation. Instead of training the entire model, LoRA freezes the original weights and injects lightweight, smaller matrices to capture new specific data. This provides advantages of cost and speed for post-training compared to fine-tuning an entire model, which likely would just be impractical. Now, Tinker already supports a bunch of open models like Qwen, Kimi, DeepSeek, Nvidia's Nemotron, and OpenAI's GPT OSS. And Inkling is one of the pricier ones, so why would you even bother with it? Well, there's two reasons, and we've covered them a little bit already. The first is audio. Out of every model on the platform, Inkling is the only one that takes audio at all. Plenty of them do images. Kimi and most of the Qwen models handle vision fine, but not one of them actually handles raw sound. And they've also shipped 3 cookbook recipes to go with it, like speech recognition and speaking style classification. So the model can tell you how something was said, not just what was said. And there's also a medical example trained on dictated prescriptions, teaching it drug names that most models would otherwise mangle. The second is thinking effort. Inkling lets you set how hard it thinks as a number from 0 to 1. Most models give you a switch of 2 to 3 settings. GPT OSS gives you low, medium, and high, for example, but Inkling gives you an entire slider. So the big question is, should you actually use it? Well, if you want a model to run as it comes, then this probably isn't it, and they'll be explicit about that themselves. But if you've got a narrow, high volume job, some real labeled data, and a way to grade the output, fine-tuning a small open model is one of the most underrated things you can do right now, and with platforms like Tinker, it's so much easier. And whether Inkling is the one you train really comes down to what you're feeding it. If there's audio going in, Inkling is a strong choice, and nothing else on Tinker even takes raw audio right now. And if you're looking for the best open generalist model right now, we've just done a video on Kimi K3 you can watch here, and that has had some incredible results. But otherwise, thank you for watching. I've been Warren from BetterStack, and I'll catch you in the next one.